Hello guys, today we'll be doing question 208 of LeetCode. The question is implement trie, which is a prefix tree. A trie, pronounced as trie or prefix tree, is a tree data structure used to efficiently store and retrieve keys in a dataset of strings. There are various applications of this data structure such as autocomplete and spell checker. Implement the trie class. Trie initializes the trie object. Void insert string word inserts a string word into the trie. Boolean search string word returns true if the string word is in the trie and was inserted before, and false otherwise. Boolean startsWith string prefix returns true if there is a previously inserted string word that has the prefix, and false otherwise. So example 1, we initiate the trie. So trie tries a new trie. We insert, so we insert apple here. We search apple, it returns true because apple is in there. We search app, returns false, app is not in there. We check if it starts with app, it's true because apple is in there and apple starts with app. And then we insert app and we search if app is there, and app is a word there. So let me show you first what a trie is. So a trie is pretty much a tree with words. So let's say the trie is here. This is the trie. And the trie has words, for example, let's say apple. So A is the trie with the children of P. Then P. Yeah, let's say app for now. Then let's say insert. Well, let's put in, just in, I, N, in, and let's say we want to add, say art. So we've got R, A, R, T. So these are the TrieNodes. The TrieNodes both have the value itself, so A, and children, in this case P and R. And the last node here would have word is true. So we know that this is the ending of a word. Same with this one. So true and true. Whereas the other ones would have false because this is not the ending of a word, unless I was inserted as a word, or if that value was inserted as a word. So when we check a prefix, let's say we check prefix of app, this is true because it's in there. If we check the word, if app is in there, it's true because it's in there. But if we search, let's say word of R, this is false because R is not a word but is a prefix. So when we insert letter by letter. Let's go back here so we can see. So we insert letter by letter, and let's say we already have a letter. Let's say we want to insert arts. So art with an S as a word. So we already have the A. So since we have the A, we go from the trie down to A. Now we check for R. R is here, so we go down from A down to R. Now T is here, we go T from R to T, but S is not there. So then we add as a child of T, S. And then here, this is the final word, we set word to true for the S. Now let me show you how to do this question. Okay, so the first thing we do is we create a new TrieNode, which is a function, and it contains two values: a child value, which is equal to an object, and a Boolean, which represents whether the node is a word or not, so the last letter of a word, which currently set to false. Then for trie, we have to set the root. So the root value is equal to an empty TrieNode. So all the following words will be children of this. Well, all the following letters of the words will be children of this root children. Then to insert, we have to get the current root. So let current is equal to this dot root. Then we get each letter. So let letter of word. Let's make it easier. So let letter of word. Make it more legible. Let letter. We can't do that. Okay, just leave it L of word. And we check if it is in the children. If it's not, we create a new TrieNode and make it a child. So if letter is not in the current dot children, then we make current dot children letter is equal to new TrieNode. And then we set current to current.children which is the letter. So if it does have it, we don't have to create one. It already is one, and so we set it to that. And then for the last one, where we're at, we set isWord to true. So current dot isWord is equal to true. Okay, now for the search function, we again get a root. So let current is equal to this dot root. Then we can loop through the word. So for let letter of word, and we check if it is a child node. So if it isn't, we know it's false. So if letter is not in the child node, so this root.children, current.children. If letter is not in children, then we return false. Else we set the current to current.children of the letter, if it is. And then we return is current.isWord. So if it is a word, return true, otherwise it will return false. Next, startsWith. So we have to check for each letter again. So we get the current value, so current is equal to this dot root again. Then again, for each letter in the prefix, then we check if it exists. If there is no, so if letter is not in current.children, then we return false. Return as it's not a word or a prefix, because there is no letter pretty much. Otherwise, we set current to the current child of the letter. And then if this completes, we return true. And let's run. If not in, let's run. Okay, swear, run. While in car.children, where's this? Line 16. Okay, let's put this in a bracket here. Do the same for the rest. And here too. Now let's run. Okay, as you can see it passes, let's submit. As you can see, it's pretty much the average solution here. And this is the time complexity of, for each function, let's see. So this one, again, is immediate, we create one. This one is ON, as we have to loop through each letter in the word. This one also is ON, and this one is also ON for each letter in the prefix. Thanks for watching.